Hello, welcome back. Today we're going to continue with chapter 10 and really get into conics and parabolas today. So what is a conic? Well, conic section was discovered in classical Greek period between 600 to 300 BC, and it's defined as the intersection of a plane and a double napped cone. So you can kind of see these cones right on top of each other. So when we cut these cones, well, we can get a circle right here. That's a conic. We can cut it this way and get an ellipse, or we can get a parabola, which we're going to look into further today, or a hyperbola. Those are the four basic conics that we're going to go through. But there are also degenerate conics, and degenerate conics go through the vertex. So we have the point here, we have a line, and then we have two intersecting lines. Another way to define conics is as a second degree equation, and we have this general formula right here, or it can be defined as a locus of points. For example, a circle is a set of all points equidistant from a fixed point, its center, hk, and we write that equation as x minus h quantity squared plus y minus k quantity squared equals r squared. Today we're going to talk about parabolas a little bit more in depth. And you probably might say that you already know a lot about parabolas because you know the quadratic function and how parabolas open up or open down. And that is true, but there are also more parabolas. So we're going to define it in a more general way. Okay, so a parabola is a set of points equidistant from a fixed line, which we call a directrix, and a point which we call the focus. The vertex is the midpoint between the focus and the directrix, and the axis of the parabola is passing through the focus and the directrix. Now, when we talk about being equidistant, specifically on this axis, the vertex is going to be p units away from the focus, as well as the directrix. So this distance here will be p. All right, so to write the standard form, we're going to use the p. So we have x minus h quantity squared equals 4p times y minus k. And then if we have a parabola that's on the horizontal axis or opening left to right, that equation will be y minus k quantity squared equals 4p times x minus h. All right, so if we look at these pairs of parabolas. So here we have parabolas that open up and open down. The vertex we know is hk, and that distance is p. Well, the focus, that coordinate will be h comma k plus p. And the directrix, that equation will be y equals k minus p. If we look at the horizontal parabolas, we again have the vertex, that's still hk, but remember it's just written a little differently here. And to find the focus, you're going to add the p to the h. So we have h plus p comma k, and then the directrix is over here. It's going to be a vertical line, so it's x equals h minus p. Okay, let's figure out how this equation was derived. So I'm going to label the key values here. So we know the vertex, well, that's hk. We know the focus, which is right above it, will be h comma k plus p. And then the directrix will have the equation y equals k minus p. Okay, so let's identify a point out here and just label it xy. So we know this point will be equidistant from the focus and the directrix. So this coordinate would be x comma k minus p. Right, so we have that equation already over here. So let's identify these values, lengths pf and pd. So PF has to equal PD. So I'm just going to plug these values in. So we know that looking at the distance, this will be x minus h squared plus y minus k plus p squared. That's going to equal, well, it's x minus x squared plus y minus k minus p squared. Okay, all right, so let's simplify this a little bit. I'm going to leave this in the squared form because we know that that's going to be a parabola. So that's y squared minus 2y k plus p squared. That's going to equal y squared minus 2y times k minus p plus k minus p squared. We know right away that the y squareds will cancel, so let's cancel those out. All right, and we'll just have to simplify this a little bit. So we'll have x minus h squared minus 2ky minus 2py plus k squared plus 2kp plus p squared equals negative 2ky plus 2py plus k squared minus 2kp plus p squared. All right, so we have some more things that are going to cancel out, the p squareds, k squareds as well. Those are going to cancel out. And the negative 2ky will also cancel. All right, let's simplify this. So we have x minus h squared minus 2py plus 2kp is going to equal 2py minus 2kp. All right, so if we combine the terms, so we have x minus h squared, we'll get 4py minus 4kp. We could factor out the p and the 4, so we have 4py minus k. All right, so that's the formula, and we derived that from the distance formula. Now let's find some equations together. We want to find the standard equation of a parabola with the vertex at the origin, so that's going to be our hk, and then the focus is 0, negative 2. And remember, if we think about where that's going to be, so this will be opening down, so we know this value for p will be negative 2. It's going down. So thinking about the equation, we know that x minus h squared equals 4p times y minus k. And if we plug these values in, we know that x squared is going to equal 4 times negative 2 times y, so that's just going to be x squared equals negative 8y. All right, for example 2, we're going to write this equation of a parabola with a vertex at 3, 2, there's our hk, and our focus is 1, 2. So thinking about that orientation, here's 3, 2, the vertex, and the focus is over here. So this parabola must be opening to the left. And we also could tell that this p will be negative 2. But the equation will be a little different. So we know that y minus k squared equals 4p times x minus h. So let's plug these values in. So we know y minus 2 squared equals 4 times negative 2 times x minus 3. So we'll just leave it in the standard form. Y minus 2 squared equals negative 8 times x minus 3. Now we want to find the equation of a parabola with a vertex at 1, 3 and a focus at 1, 5. So this parabola will be opening up. Here's 1, 3 and 1, 5 is up here. And our p-value, again, will be 2. So we're going to solve this for y. So we have the equation x minus h squared equals 4p times y minus k. I'm just going to solve this for y right now. Let me just flip it around. We have 4p y minus k equals x minus h. Y minus k equals 1 over 4p. X minus h squared. So y will equal 1 over 4p x minus h squared plus k. And I do like that form in vertex form. Okay, so we're going to just plug the values in. So we know that p is 2, and so we have y equals, let me use a different color. So y equals 1 over 8, because it's times 2, x minus 1 squared plus 3. And this is really interesting, and I really want to make sure we point this out, that A equals 1 over 4p. So if A equals 1 over 4p, p will equal 1 over 4a. Okay, so here we have, for the next example, we want to find the focus of the parabola given in this equation. So we need to know the vertex, and then we can find the focus when we have p. I'm just going to simplify that equation. So we have y equals negative 1/6 x squared minus 2/3 x plus 1/3. We know that for the vertex, well, h equals negative b over 2a. So that's going to be negative, well, that's just 2/3 over 2 times negative 1/6. So that's 2/3 over 1/3. So that's just going to be, that's negative. So that'll just be negative 2. If we want to figure out the k, we just plug that into the equation. So that's negative 1/6, negative 2 squared, negative 2 times negative 2/3 plus 1/3. So the k will equal 1. So our vertex for this equation is going to be negative 2, 1. All right, now we can figure out the p. And so I'm going to go back to here. So we figure out p is equal to 1 over 4a. So we know that the a is negative 1/6. So p will equal 1 over 4 times negative 1 over 6. So that's just going to be 1 over negative 2/3. And let me simplify that. P is going to equal negative 3 over 2. So that means going down. Okay, so to find the focus, we're going to use the vertex and subtract 3/2 from 1. So really negative 2, 1 minus 3 over 2. So you just simplify that, so it's negative 2, negative 1/2. There's so many applications of parabolas, specifically with the focus and directrix. So a couple more vocabulary words I want to just go over is the focal chord. Well, the focal chord is a line segment that passes through the focus and has an endpoint on the parabola. And then a latus rectum is the focal chord perpendicular to the axis of the parabola. So it'd be over here. When we look at satellites or flashlights or anything that's using this parabolic reflection, these rays, or this is a light bulb right here, they're going to be bouncing off the parabola or the case in the flashlight and be concentrated to one area. And conversely, if the rays are coming in like a satellite, they're going to be reflected to the focus so that all those signals are being concentrated and we can get a good signal. Let's look at this problem. So here we have a satellite dish mounted on the roof of a building, and we want to write the equation for the parabola. So we're given this height is going to be 3. So I could actually write the coordinate as 1, 3. And this coordinate would be 1, negative 3. Okay, so what we're going to do is use the general equation. So we have y minus k squared equals 4p x minus h. So here we have the vertex at the origin. So I'll rewrite this as y squared equals 4p x. All right, so we do know one of the points, we have 2 points on the parabola. So I'm going to substitute the values 1, 3 into the equation. So we have 3 squared equals 4p times 1. So we can solve for p, and that will be 9 over 4. So if we know that p is 9 over 4, then we just can easily write the equation because we know that a equals 1 over 4p. So 1 over 4 times 9/4 would be 1/9. So we have the equation y minus k, or y squared, equals 1/9 x. All right, there's one more property I want to go over with parabolas, and that's the reflective property. So if we have a point that's on the parabola and its tangent at that point, P, it's going to create equal angles. So the line passing through P and the focus, and then the line or the axis of the parabola. So we can see that these values, you can see these angles here are going to be congruent, shown by alpha. And these sides are going to be congruent. And we can see that that's going to be an isosceles triangle. All right, so we're going to use that knowledge to write the equation of the tangent of a parabola given by x squared equals 2y at the point 3, 9/2. So I'm just going to sketch this really quickly. This is going to be just like this. And I'm going to use a different color and just say that this is 3, 9/2. Okay, so just like we have the reflection property, the focus would be here, and these would be equidistant or equal length. Okay, so let's identify a couple points. So the point on the axis, well, this is the F, the focus. We know that if the parabola is at the origin, and the equation is x squared equals 2y, well, that's very similar to x squared equals 4py. So we know that 2 must equal 4p. So p must equal 1/2. So if we know p equals 1/2, we can figure out the coordinates for the focus. So the focus must be at 0, 1/2. Now if we wanted to find those lengths, I'm going to label this as D1 and D2. We can also identify or label the y-intercept. So I'm going to label that here as 0, B. And if we wanted to find the distance between the focus and the y-intercept, that'll just be 1/2 minus B. To find the length of D2, that's going to be 3 squared plus 9/2 minus 1/2 squared. So that'll be 9 plus 16. So D2 equals 5. Since we know that D1 equals D2, we can set up the equation. So 1/2 minus B will equal 5. And this will be 9/2. So B must be negative 9/2. So if we know this coordinate is going to be 0, negative 9/2, well, now we have 2 points, so that's easy. Right, so we could say, all right, the points are, I'll write them over here, 3, 9/2 and 0, negative 9/2. So to find the slope, that'll just be 9/2 plus 9/2 over 3. So that'll just be 3. And our equation will be y equals 3x minus 9/2. I hope that was helpful, and I'll see you all in class.